We are now into the final routing protocol that we'll talk about in this CCNA video, and that is EIGRP. EIGRP is Cisco's direct competition to OSPF. It is, unfortunately, proprietary. EIGRP is without a doubt, in my mind, the best routing protocol on the planet if you have Cisco routers everywhere and your corporate policy does not prevent you from using proprietary protocols. A lot of corporations really steer clear of that. So we're going to look at, as we go into this video, why I think that. The good, the bad, and the proprietary of EIGRP. We'll then go into the configuration of EIGRP, look at features like auto summarization, how we can set it up on our routers, and we'll replace our whole network that's currently running OSPF with EIGRP. We'll even, I believe, go into some of the summarization features of EIGRP, just like we did with OSPF, kind of take a step beyond CCNA, and then we'll verify everything to make sure it's working correctly. Now, EIGRP is the last routing protocol we're going to talk about, so we have to answer the big question of why initially. Why would I use a proprietary routing protocol over OSPF or over RIP? Well, first and foremost, EIGRP is the only routing protocol in the world that allows backup routes. Now, I want to make sure I phrase that correctly. Backup routes are allowed by every routing protocol, as in, if this goes down, it will fail over to this. But with EIGRP, backup routes are remembered. Here's the idea. With OSPF, let's say OSPF or RIP, when they find the best way to get somewhere, they take that best way and they put it into the routing table, and then they forget about all the other paths that were once there. All of the backups. So if the primary or the best way that's in the routing table goes down, OSPF and RIP have to rediscover or relook at the network to find all the backup routes and then find the best one of the backup routes and put that into the routing table. Not with EIGRP. EIGRP uses backup routes in something known as a topology table. So whenever it finds the best way and that goes into the routing table, it says, oh yeah, router. It speaks to itself. It says, if you ever lose that best way, I've got a perfect backup right here. So EIGRP is running along, life is good, the router's just sending packets, humming along, and all of a sudden, wham, a tractor out front hits the primary link to the internet. EIGRP detects the failure and immediately says, whoom, here is the backup route. No real calculations are necessary. It just says, I've got it right here because I tagged this as a backup route when we initially calculated the routing table. And you can see that little dual algorithm there. Dual stands for diffused update algorithm. What it is just the engine that runs EIGRP. With OSPF, the engine is known as SPF. It's the algorithm that the guy who created OSPF, his name's Dijkstra, created. The problem with OSPF and the SPF algorithm is that it is very hard on your router's processor. So as your router's chunking out that routing table, trying to find backup paths, it is increasing the processor load on there. With EIGRP, dual is much easier on the processor and memory. So that's the number one reason why you choose EIGRP, the only protocol to remember backup routes. Second reason is that it's easy. Cisco's goal with EIGRP was not to have a super complex protocol, but they wanted a protocol that could do all the same things as OSPF, but be easy. Meaning take the easy to configure aspects of distance vector like RIP. RIP was really easy to turn on. Take those features and combine them with all the advanced features of link state and get a simple config. Third reason you'd use EIGRP, flexibility in summarization. With OSPF, now think back, what was the only place we could summarize in OSPF? At the ABR, at the area border router, between areas. Well, in EIGRP, there is no concept of areas because you can summarize whenever and wherever you want. I'll actually do that in this video. As we get into the configuration, I'll show you this is how we go under an interface and just throw in a summary route wherever we want it. And technically, I guess you could say, create an area boundary. Fourth, EIGRP is the only one that allows unequal cost load balancing. Every protocol, even static routes, allow you to do equal cost load balancing. One packet here, one packet there. EIGRP can actually take a network, analyze it, and say, well, I've got, let's say I've got two routes to the same network. Got some routers, a little LAN over here. And router 1 right here is trying to decide. And over here it sees a T1 line, which is 1.544 megabits per second. And over to the right up here, it sees half T1 line, which would be 768 kilobits per second. That's exactly half a T1. Every other routing protocol in the world would say, you are the best, my friend, and you go in the routing table. And this one would just sit here as a backup, or it would just be unused, thrown away. So that would be idle bandwidth that's just sitting there. Now, with other routing protocols, you could tune it and you could actually lie to the protocol and go under the interface and say the bandwidth of this interface is such and such, and make it exactly equal to a T1 line. And every other routing protocol would send one packet here, one packet here, one packet here, one packet here. But the problem with that is then it has to drag this T1 down to a 768K speed so that it can equally distribute the load. So the point is you just can't load balance over unequal cost paths with other routing protocols. With EIGRP, you can set it up in such a way where you can type in a variance command and say, well, I'll take a variance of 2, which says exactly half. At that point, the router will load balance across links that are half as good as the primary. And I don't want to get too deep into the variance command, but that will say, EIGRP will say, okay, well, I notice that I have a 768K link here and a 1544K link here, or 1.544 megabit link. This is exactly half, so I'll send 2 packets on this link for every 1 that I send over here. Unequal cost load balancing. By doing that, you are effectively combining these into one logical link and using that bandwidth to its best. So the backup doesn't just sit there as idle bandwidth you're paying for but not using. 5, I mentioned that already, combines the best of distance vector. That's the easy to configure side of it and all the advanced feature of link state. 6, and this you got to throw this in here, supports multiple network protocols. I would say maybe 8 years ago, this was a cool feature. Maybe even longer than that. Back when we were using protocols like IPX, SPX, and AppleTalk, EIGRP could support them all. Nowadays, all we use is TCP/IP, and that, I guess you could say it's still a feature. It's just hardly anybody uses it. Now let's get into how EIGRP works. EIGRP routers maintain 3 separate tables: a neighbor table, a topology table, and a routing table. When you first start running the protocols, the neighbors will discover each other. And just like OSPF, EIGRP discovers neighbors and uses the hello protocol, or a hello message, to say, hi, are you online, and exchange hello messages between them. Now, EIGRP is not as strict as OSPF with what neighbors it can have, so it can more easily form neighbors. But once the neighbors are formed, they will exchange routes. Now, all of those routes go into a topology table. And this is EIGRP's roadmap of the network. It will remember all of the best routes and all of the backup routes in that topology table as little flags. So for example, let's say, well, this network isn't very redundant, but let's say it is. We've got a link right here. So router 1 has 2 ways that it can get to the 10.1.2 network. The best route will go into the topology table and be marked as, and this is getting into some of the terms, a successor. A successor. That's like the primary route that is going to be chosen. And let's talk about the other table. That one gets moved into the routing table. That is the one that will be actively used by the router. Now, router 1 also notices that it can go through router 2 and then through router 4 and get to this network. And it says, you know what? Let's go ahead and add that guy into the topology table. So I'll have the 10.1.2.0 network over here. And I will mark that one as a feasible successor. Now I know, that these terms can be kind of confusing, at least for myself when I started thinking about them, let me finish writing there. Successor, I almost think about like a throne, and I think, oh, well, the successor to the throne. So that would be a backup, right? Well, you got to kind of change the logic. The successor is the one who is, this is the way I remember it, is succeeding. They are the best, you know. I'm very successful, you know. They are successful in what they do. So the successful one ends up in the routing table. That's the primary. Feasible successor is the one that stays in the topology, but it gets flagged. I put a little B here. It gets flagged as the backup. So if life is good and going along, and all of a sudden, wham, the bomb hits, and this router 1 to router 4 link dies, this immediately drops out of the routing table as the successor because it's down. EIGRP says, whoop, I've got that feasible successor, and slide it right in there. With a little tuning, EIGRP can support something known as sub-second convergence, meaning your network recovers in less than a second. And it does take some tuning to get there, but that's the kind of level you can reach. Now let's get into configuring EIGRP. I have the same topology set up as I did when I configured OSPF, but now we're going to convert it to an EIGRP environment. So we'll start off on router 1 up here, and the first thing I'm going to do is go into router 1 and turn off OSPF. No router OSPF1. Goodbye. I'll then go in and do router EIGRP, oops, router EIGRP, question mark, and you can see autonomous system number. Now you might remember with OSPF, this number was the process ID. In EIGRP, this represents the system that you are in. And unlike OSPF, it must be the same on all the routers in your network. So if I go in here and type in router EIGRP 10, which I'll do right now, I've created the autonomous system 10. And all the routers in my company have to be in that same autonomous system. Otherwise, the EIGRP will say, oh, you're not my company. I don't need to exchange routes with you. So once we're under the router EIGRP process, we turn on EIGRP in the same way that we do every other routing protocol. So I'm going to type in show IP interface brief. This is my internet router. I've got the 192.168.1.1, and that's my internet link. I don't want to run EIGRP on my internet link, or else I could form relationships with my internet service provider if they happen to run EIGRP. That'd be very doubtful, but you never know. So I can type in network 192.168.1.0. Now remember, one of the criteria that Cisco wanted to meet was they wanted to make this as easy to configure as RIP, but have all the advanced features that link state protocols have. So here we are at the network statement. If we were in RIP, this would be all we have to type. We hit the enter key, and it starts running on any interface that starts with 192.168.1. You remember, think back, RIP is, you have to type in class full networks, meaning whatever the default class of network is. So if I had 10.1.1.1 interface, I would type in my network as 10.0.0.0, enter, because the 10 network is a class A network. Now right here, I'm typing in network 192.168.1.0. It will work if I hit enter, but watch this. I hit enter and it says you can either, or hit question mark, I can either hit enter and just use it like I'm using RIP, or I can allow wildcard bits. Now wait a sec. That's an OSPF thing. You better believe it. And that's what EIGRP can do. You can go in and say, I want to use it as simple as RIP, or I want to use it, with the complexity, and I should say complexity and flexibility of OSPF. Because with OSPF, you can really get specific as to what interfaces you would like to enable EIGRP on. So I hit enter and I'm done. EIGRP is now sending hellos out the 192.168.1 interface up here at router 1. Let's hop down to router 2. Router 2, I'm going to get into global config mode. You want to know something? You can't hear me type anymore, can you? That's because my wife bought me a brand new keyboard. It's awesome. It's an Apple keyboard. Have you seen these things? These things are like razor thin, and you can, they're literally super thin, and you cannot hear me type. And it was, I'm sure, a little selfish motivation on her part, not to throw her under the bus. I'm sure it was she had a great heart and thing. But when I'm in here and I'm typing, I'm slamming on that keyboard and it's loud. And she's, oh, you type so loud. Come on. And so this keyboard, he can't hear me anymore. Anyhow, so I'm going to type in no router OSPF1. I'm turning off OSPF. Killed the neighbor. Now I'm going to type in router EIGRP10 to be in the same autonomous system. On this one, let's do a show IP interface brief. And there's all my 192.168 networks. I'll do network 192.168.0.0 question mark, and there's my option for wildcard bits. Oh, that's so helpful. If I were using this with RIP, I'd have to type in a unique network statement for every single one of these. Network 192.168.1.0, enter. 192.168.10.0, enter. 192.168.20.0, enter. Here I can just say 192.168.0.0.0.255.255, which again says I care about 192, I care about 168, I do not care what comes after that. So I will automatically run EIGRP on every interface starting with 192.168. And right there we can see a neighbor relationship has formed, a new adjacency. I'm going to type in show IP EIGRP neighbors. You have to spell neighbor. Okay, I'll go back and do a show, hang on. Show IP, I spelled EIGRP wrong. EIGRP neighbor. Must be this new keyboard. All right, so there we go. We've got the neighbor. We see the address, 192.168.1.1. That's our router 1. I can see the interface I've formed a neighbor on. I can see how long that neighbor's been running. I can see the hold time. Hold time is how long it believes until that neighbor is dead. By default, EIGRP says hello once every 5 seconds. So if the neighbor stops saying hello for any amount of time, you notice the hello timers, 11 seconds, 10 seconds, oh, back up to 14. That's because this guy is saying hello once every 5 seconds. Hello. As soon as this guy receives a hello, it starts the countdown. It says, if I don't hear another hello from you in 15 seconds, aka hold down timer, you are considered dead and I will no longer use your routes. And that's why you should never, hopefully, see this hold timer go below 10. Because if it does, that means you're missing hellos. You see it go down to 10 and back up because it received another hello. SRT, I won't get too deep into this stuff, but that stands for source round trip timer. That's how long it takes to get to the neighbor and back. And that helps it gauge how long it should be waiting before it expects a hello. Now over here, H, that is the most unknown column to anybody in EIGRP. I challenge you to find, what does H stand for? And I'm serious, nobody really knows. I can tell you what that column is. It is a list of the neighbors in the order it was received. So for example, if router 2 gets another neighbor, which it will be H1, and then 2 more neighbors, it will be H2 and H3. Those are the order it learned about the neighbors, but nobody knows what H really stands for. I know somebody suggested hop count, but hop count, your neighbor can only be 1 hop away or no hops away. Otherwise, you're not neighbors. You're remote, distant cousins. So anyway, mystery, hop. So I'm going to go over to router 3. Let's get that guy running. New router OSPF1. We're killing that guy. Router EIGRP10. Go into there. Network. And let's check out router 3. Okay, he's 192.168.3 and 2. So I'll do, let's do 192.168.0.0, and we'll use the wildcard bits. That gets it running on all the 192.168 networks, and poof, it forms a neighbor. That's fantastic. And this one is the one that has all the loopback interfaces. So we can advertise those as well. And that way I can also show you summarization with EIGRP. Let's do network 172.30.0.0. And we'll add in 00255.255 as our wildcard bits. So it automatically runs on all of these interfaces and advertises them to the rest of the network. Super. So at this point, I should be able, well, I'll stay on router 3, to do a show IP EIGRP neighbor. And there's my neighbor I learned about. This is router 2. That is router 3's neighbor. I can do a show IP route. And I should be learning at this point D routes. D as in dog. D stands for EIGRP because E was already taken by the external or EGP, external gateway protocol. So Cisco said, well, let's use D. So all routes learned by EIGRP is going to be represented with a D. Now you can see right here 192.168.20.0, 192.168.1.0 are all in the table, and there's all my loopbacks and so on. But I want to show you something. Let me show you something. I'm going to go over to router 2. I'm going to do a show IP route. Prepare yourself. Wait a sec. Where's all the loopbacks? 192.168.30.5 and 4 and 7. Where'd they all go? Uh-huh. Look at that guy. 172.30.0.0/16. What we have experienced is my least favorite feature of EIGRP. It is a feature known as auto summarization. What EIGRP does is anytime you have a network that is advertised across a boundary that is not the same network, it will auto summarize. Let me give you an example of that. Right here, I have a network. It is a class B 172. Oh, I still need to fix that. Good grief. It's 172.30 networks, right? You guys have seen that. Wow, I just goofed up my screen a little bit, but that's all right. 172.30.0.0, that's the networks that this represents. That's a class B network, and that's one class of addresses. Now up here, I have a class C network, 192.168.2. Remember, class C addresses start with 192, and that goes through 223. So there's a class C network. Over here, class C network. So when I advertise some it's actually technically called a discontiguous network, a network that is not of the same type or same class as this network across that boundary. EIGRP thinks it's doing me a favor, and it will say, well, I'll tell you what, I'll auto summarize that back to its default class B boundary. Remember, by default, 172.30 is a class B network. Let me get my screen moved up here. There we go. It is a class B network, so it will auto summarize back as if it was a class B network all over again. That's a class B subnet mask. Now, I don't like that feature. Whenever I hear anything in auto, in Cisco that's auto, I think I auto not use that. No auto feature is good, or I should say very, very few of them are. Now, let me give you another example. If up here at router 1, I had 10.1.1.0/24 and 10.1.1.2.0 and 3.0. Now I've subnetted those with class C subnet masks, but when they are advertised over here, this is a discontiguous network. I'm not advertising it over another 10 network. So EIGRP would auto summarize back to this 10.0.0.0/8. Because it thinks it's doing me a favor and just auto summing them up. Now, some people like that, and that it's very distance vector protocol-ish to do something like that. There's other protocols that do that, like RIP, but I don't like that. I like control over where my summary routes go. Because you know what? I could come up with a much better summary route than 172.30.0.0/16. Because if I use that, it kills the whole 172.30 range, because all these routers believe router 3 has everything to do with 172.30. So I'm thinking I need to turn off that feature, and here's how you do it. Holy cow, was I typing and you couldn't see what I was typing for a little bit? Forgive me, I hope not. I got to review this video and make sure it looks okay. Okay, so where was I? Oh, auto summarization. The way that we turn it off, router EIGRP 10, is I can type in no auto summary. I just think no auto, no auto. That's what we need to type. It resets the neighbor relationships and will reform them. It says summary reconfigured. I'm going to go up to router 1, router EIGRP. Got to do it on all of them. No auto. Router 3, router EIGRP 10, no auto. Turn that off on all of them. No auto summary. So that will reform all those neighbor relationships. And now look what happens. I go over to router 2 and I see when I do a show IP route that I am now getting all the more specific routing information from that router. It does not auto summarize that into 1/16 block. That's good. Now let me go back and show you how I can inject a manual summary route. I had to pause the video there for a moment to make sure I didn't cut anything off when my screen jumped around, and I didn't. That's good. So I'm going to go to router 3, and actually, let me stop right there and first mention, if you are a CCNA candidate, I have talked about everything you need to know for CCNA. For the EIGRP. I'm about to show you a cool CCNP concept, but again, very simple, and it's a way that you can make your network much more efficient. I'm going to go on, we're going to the place where all those routes came from, router 3. Show IP route, I can see that I've got all those directly connected 172.30.6. Now, you remember if you watched the OSPF videos that I was able to summarize at the ABR. In EIGRP, I can summarize anywhere. All I need to do is go under the interface that I want to send the summary route out of. So on router 3, I want to go underneath serial 0/0 because that's where I'm going to be sending the summary route out of. I'm going to go serial 00, and I'm going to type in IP EIGRP. Oh, hang on. IP. Wait a second. Oh, I jumped ahead of myself. IP summary address. Good old context-sensitive help. For EIGRP. That's the protocol that I want to do. What autonomous system? Autonomous system 10. Do question mark, and it says, what do you want your summary route to be? I'll do 172.30.0.0. Now, in the last video on OSPF, we figured out the best summary mask for the 172.30 networks would be 255.255.248.0. And that would summarize 0 through 7. Now, I know we added 8 in there, and we'll see how EIGRP handles that. I'll put 255. And it's going to, let me hit the question mark, 255.248.0. It's asking for that summary mask. And I'll do space question mark. And if you want, you can tune the administrative distance, which is the believability of that summary route. I don't need to do that. So I'll hit enter. And now it's going to create this neighbor change. You know, it kind of downs the neighbor and comes back up and says a new summary is configured, new adjacency is brought up. I'm going to go over to router 2 now and do a show IP route. Now look at that. There's my new summary route that encompasses 0 through 7, and it automatically advertises 8 as a separate network because it realized that's not encompassed in my summary route. Now I want to show you one more thing. And this is going to be a massive concept. What I mean is in how this affects your knowledge of routing. Not so much a big, like unbelievable concept. All right, here we go. Look at that. You see, in the router that is sending the summary route, it says I have 172.30.0.0. That is a summary route that I typed in. And I'm sending all traffic that is sent to that summary route to null 0. Null 0 is the garbage can. What? That means any traffic that it gets that matches this summary route, the router is going to automatically send to the garbage can. It's going to drop that traffic. Now, why would it do something like that? Well, think about this. All of these routes have a very specific submask, /24. When we create a summary route, let me put that up here, 172.16.0.0/21. That's our summary route. That encompasses 0 through 7. What if this one didn't exist? What if our router 3, had 172.30.0.1.2.3, 5, 6, and 7. And we said, oh, well, that's all right. Let's just create a summary route for all of those. And we'll just not use .4 anywhere. Well, the way EIGRP works is if it gets a packet for the 172.30.4 network, it will start asking other routers with these things known as query packets. And it will say, other routers, can you find a way to the .4 network? And they'll say, I don't know. And they'll start searching the whole network, causing all this traffic to try and find a route to a network that doesn't really exist. So what this null 0 route does is it says, you know what, if you get a packet for something you don't have a more specific route for, then throw it away. Here's what I mean. You've got all of these routes in the routing table. Notice this. 1, 6, 7, and the router organized these as its own will, whatever it thinks it's going to use first. So we've got this organization right here. These are all more specific subnet masks. Rule number one of routing. It doesn't matter what routing protocol you have, what you're running, is if it has a more specific subnet mask, it will use that. So here's what I mean. Router 3 gets a packet for 172.30.3.50, looks at its routing table and it says, ah, 3.0, I've got a match. It needs to go out loopback 3 interface. But then it looks and it says, oh, wait, I've got another match. 172.30.0.0/21, that includes 3.50. That really represents 00 through 7.255. So 3.50 is included in there. So it looks and it goes, well, I'm not going to use that one because I have a more specific route. The better the subnet mask, the more specific the subnet mask, the better the route is. So this will never be used as long as it has a more specific route right here. The only time you'll actually use this route to the garbage can is if one of these more specific routes that don't exist, and that means the network doesn't exist. So that's the idea behind that null zero route. And that idea of specificity in those subnet masks is big. That is the core of the EIGRP routing protocol. As you can see, EIGRP is far easier to configure than OSPF and multiple areas and all those kind of things. And as you get into the more advanced CCNP curriculum, you'll even see that ease come out more and more. That ability to summarize on any interface is a big one when you're looking for good features in a routing protocol. So we saw the reasons that you would look at EIGRP as a good replacement for your organization. That was the fact that it never throws away routes. You can summarize at any point in the network. The algorithm it uses, which is known as dual, is far more efficient than the OSPF routing protocol. And it is the only one that can load balance over unequal cost paths. We saw EIGRP auto summarization, which is a feature that I don't like, that EIGRP will summarize networks back to their classful boundary anytime you advertise them across a discontiguous link. Best thing you can do for your network is to go in and type in no auto and put in manual summary routes wherever you need. Last but not least, in no specific order, we saw the EIGRP configuration and verification. Simple commands, router EIGRP and the autonomous system, followed up with your networks. Verify by doing a show IP EIGRP neighbors and show IP route. I hope this has been informative for you, and I'd like to thank you for viewing.